Every year, millions of tons of animal bones are discarded as waste from meat processing facilities around the world. But what if this waste could become something valuable? These bones contain a hidden treasure: collagen and gelatin. Cattle, pig, and chicken bones, all destined for transformation. The journey begins at bone collection facilities. Tons of bones arrive daily, fresh from processing plants. First, workers assess the quality and type of bones.
Sorting is crucial. Different bones require different processing methods. Sorted bones move to the next stage: intensive cleaning. Industrial washers remove blood, tissue, and organic matter.
High-pressure water jets blast away contaminants. Every crevice must be thoroughly cleaned. Bones tumble for hours in alkaline cleaning solution. Next, degreasing removes all fat and marrow. Hot chemical baths dissolve fatty tissues. The fat rises to the surface and is skimmed off. Technicians constantly monitor solution concentration.
Multiple tanks ensure thorough degreasing at different temperatures.
Constant agitation ensures even treatment. After 12 hours, the bones emerge pristine white. The difference is remarkable, from waste to pure material.
Fresh water rinses away all chemical residue.
Excess water drains away, leaving bones ready for drying.
Industrial dryers remove all moisture. Hot air at 200 degrees Fahrenheit ensures complete dehydration.
Every trace of moisture must be eliminated. Temperature control is critical for optimal drying.
Dried bones become lightweight and brittle.
The drying process makes bones easy to crush.
Next comes the crushing stage. Dried bones are fed into industrial crushers. Hardened steel blades pulverize the bones. Bones shatter into progressively smaller pieces. The first crush produces large fragments. Vibrating screens sort fragments by size. Multiple crushing stages create increasingly fine particles. The final product is a fine, talc-like powder. Pure bone powder collects in sterile containers. Quality control checks powder fineness.
Microscopic analysis ensures particle uniformity.
Powder is stored in climate-controlled silos before extraction. Now begins the chemical extraction process. Bone powder is loaded into acid extraction tanks. Diluted hydrochloric acid is carefully added.
Acid dissolves calcium phosphate, releasing collagen.
The reaction produces carbon dioxide gas and heat.
Temperature is continuously monitored.
Industrial stirrers ensure complete reaction.
pH levels must be precisely controlled.
Collagen proteins begin to separate from minerals. These protein fibers are the foundation of gelatin.
The solution passes through multi-stage filtration.
Filter presses remove calcium residue and impurities. Pure collagen solution emerges crystal clear. The acidic solution is carefully neutralized.
Controlled heating concentrates the collagen. As water evaporates, gelatin forms.
Viscosity tests determine when gelatin reaches optimal concentration.
Liquid gelatin is poured into cooling trays. As it cools, gelatin solidifies into sheets. This is pure bone-derived gelatin.
To create cosmetic-grade collagen, hydrolysis is required.
Solid gelatin is cut into small pieces. These cubes feed into hydrolysis reactors.
Reactors break down gelatin into smaller collagen peptides.
Multiple reactors process gelatin simultaneously.
Heat and pressure break collagen's molecular bonds. Specific enzymes accelerate the hydrolysis process.
Enzymes clip collagen chains into precise peptide lengths. This creates low molecular weight collagen peptides. Samples are taken for molecular weight analysis. Chromatography confirms peptide size distribution. The result is a solution of bioactive collagen peptides. Purification removes residual enzymes and impurities. Ion exchange resins remove charged impurities.
Ultrafiltration membranes ensure peptide purity.
The purified peptides are perfectly clear. Spray drying converts liquid peptides to powder.
Fine collagen peptide powder is created.
Collagen peptides now enter cosmetic formulation.
Precise measurements ensure formula consistency. Collagen is combined with complementary active ingredients.
Hyaluronic acid enhances moisture retention.
Ingredients dissolve and integrate at molecular level. Homogenizers create uniform emulsions. Oil and water phases blend into stable cream.
Microscopic oil droplets suspend in the water base.
Thickeners create the perfect cream consistency.
Texture must be smooth and easily absorbed.
The cream achieves a silky, premium texture. pH is adjusted to match human skin.
Safe preservatives ensure shelf stability.
Subtle fragrance enhances the sensory experience.
Automated systems fill containers with precision. Each jar receives an exact measured dose. Airtight seals preserve freshness. Every jar undergoes visual inspection. Elegant labels identify the premium product. The label highlights key collagen benefits. Jars are packaged in protective cartons. Secure packaging protects during shipping. Finished products await global distribution. From waste bone to premium anti-aging cream.
The science behind collagen peptides is compelling.
Collagen peptides penetrate the skin's outer layers.
They stimulate fibroblasts to produce new collagen.
Clinical studies show visible improvement in skin elasticity.
The cream absorbs quickly, leaving no residue.
Peptides deliver benefits deep into the dermis.
Hydration levels increase significantly.
The cream is available in multiple sizes.
premium packaging reflects the product's quality. These products reach premium cosmetic markets worldwide. From waste bones to collagen peptides to premium cream. A sustainable solution that turns waste into luxury. This process exemplifies the circular economy in action. The future of sustainable beauty manufacturing.